Welcome to this session. I hope that you're enjoying the Conf42 conference dedicated to observability, and thanks for joining my session. So, what are we going to talk about? This session is all about OpenTelemetry, but in a specific context, the event-driven architecture. My name is Henrik. I'm a cloud-native advocate within Dynatrace. And prior to Dynatrace, I've been working 15 plus years as a performance engineer. Performance is pretty much still in my heart. So that's why I'm producing content for a YouTube channel podcast called PerfBytes. So this is the icon with the red is PerfBytes. And then 1 year, less than 2 years, I would say, I've started a YouTube channel called Is It Observable, where I try to provide content for anyone who wants to get started in the observability world. All right, so we're going to talk about in the next 20 or 30 minutes or so. A couple of things. So first, obviously, you heard in the title, OpenTelemetry. So we're going to obviously talk about OpenTelemetry. We look at the various components involved in OpenTelemetry, how to produce traces, because today we're going to focus mainly on tracing. Then we're going to jump into our topic of today, which is event-driven architecture, and see the various way of instrumenting your event-driven architecture application. And of course, you will see that we will have some disadvantage. So that's why we're going to jump into span links. We'll explain what is span links and how you can utilize them. So before we start, let me tell you a story. So when I was a kid, I really loved to draw, to paint, to create basically content. And because my grandma and my mother teach me how to draw things. And it was pretty funny because when I started my first job, when I started in the industry, I was assigned into an engagement as a consultant. And at that time, in that technical environment, my manager, we were basically managing different servers, different applications. And my manager said, hey, we need to draw or we need to visualize the current behavior of our application. And that time, we were having a couple of tools like Top and Mon and so on. Those tools are pretty much precise, but give you points. So with the help of those points, the only thing that was able to draw was this. So basically like a list of points. So you can think about it's very zoomed in, so like a pixel. So it's very hard to understand the entire context of our application. But with the tooling, I was able to do that. Then 20 years ago, we had improved our solution. So we were able to store data. So we have history. We were attaching the data that we were collecting with metadata coming from CMDB, for example. So we had a more context. And because I was having stored points, I was able to draw lines. That's why I started to have a shape of the health of my web server. Then 13 years ago, the industry provided a couple of great products called APM, Application Performance Monitoring, that was allowing us to provide out-of-the-box distributed traces. Yes, distributed traces was out there at that time. Metrics, it was also having some static monitoring, some real user monitoring, and so on. So with this, at least, we had a better understanding. And so I was able to start drawing the eyes, the nose, the mouth of the actual server that I was trying to represent. So much better. At least we still understand what we have here. Then 10 years ago, because we were producing so much logs in our environment, we thought, why don't we start utilizing them? So we were parsing the logs, indexing them, and try to get even more value out of all the effort that we were doing in terms of producing logs. So at the end, we were better. That's why I'm having the arms now on the server, but still, it's not perfect. Let me show you what I thought to draw and to show to the project. This is the actual drawing. So you can see that I have a kid and the shape of the kid. So better, like a draft. And then the kid was basically in a forest or in a park or in a garden. So there was something surrounding the kid. So, unfortunately, with the toolings that I had, I was not able to basically draw what the current situations. So At the end, why I'm telling you that is because observability is not a science. Observability is like an art. You basically see things and then you start visualizing this. So you need a couple of tools like pencils, you need to have pastels, you need various colors. So let's jump into the various toolings that we have to basically build the art of observability. So what are the artistic tools? Well, as you know, observability is about understanding our current environment. So for that, we need logs. We talked about it a couple of minutes ago. We need events. So events could be basically a system like Kubernetes generates tons of events. But you also have events from your building, your pipelines, all the solutions that basically make your solution going to production. So you have a lot of rich information that give even more context to the current situation. Then we have metrics, we're used to that. Traces, we talked about it. And now with you see that traces is becoming very popular. And then we have profiling. So profiling is basically one of the signals which is very powerful because when you look at traces, you obviously want to go down to the code and profiling will help you to do so. But those pillars, those toolings are great, but you need to add context because without context, it doesn't make sense at all. So what are the contexts? We need the technology, where it's been deployed, which server, the service, if it's a Kubernetes environment, so the deployment file, the namespace, the pod, the version number, very important, the geo, where is that server located? If you have multi-cloud deployments, maybe also the geo where this server is coming from. So at the end, the context is rich because it will help you to correlate the data that you have been ingesting in your backend. But again, a natural reaction from the market, if you look around you, a lot of organizations and a lot of engineers have started to implement observability, but if you pay attention, they were using dedicated tools that were very specific for each signal. So for example, metrics, I'm going to store it in Prometheus. For traces, probably Jaeger. For logs, I want to use Elasticsearch. So at the end, we have observability, but everything is disconnected. So pretty much separated. So we are not efficient. So we'll need to stop doing this. And we need to keep everything together so then we are more efficient, especially when we need to troubleshoot and understand a given situation. So that's the purpose of the OpenTelemetry project. The OpenTelemetry project, for those who never heard about it, OpenTelemetry is an open standard. So it doesn't provide any storage. It doesn't provide you any software. It's basically provide you libraries on helping you to build a standard format observability. So standard format for distributed traces, standard format for metrics, for logs, and so on. So at the end, we will put something in our code, like an SDK. There's another component we'll talk about in a few seconds. And then with those SDK, we'll be able to produce observability data. And that framework will add in top of that the metadata that we're looking for. So the semantic convention, so the server, the HTTP request, anything that we are related to our data. So if we want to summarize the OpenTelemetry project in a very simple way, you have two things. You have the instrument, so the SDK. So at the end, I've got a guitar. I'm going to produce logs, metrics, and traces. But I can play my guitar like this. But if I want to propagate my sound or change the sound on the fly, I'm probably going to use an amplifier. So that's the collector. I will send my sound to the collector. I will be able to add some effects like chorus, overdrive. And then with the collector, I'll be able to amplify the data to send it to any observability backend of our choice. And as you know, any amplifier, you can have a second output. So you can send the data to several observability backend of our choice. At the moment, OpenTelemetry supports several types of signals. So the first one that has been initially supported was traces. So now it's stable in most of the language that we use today. Metrics is also stable for most of the language except two of them, PHP and I don't remember the other one, to be honest. And last, we have logs where it's under construction. So we should expect it probably in Q3 or Q4 of this year. And we have continuous profiling. The specification is on the way, so we should not expect it until next year. So how do we produce traces? Because today we're going to focus mainly on traces. A couple of things. So first, traces. For this, you will produce traces. You can do it in various ways, but we will still need to add an SDK in our code. And there is two ways. The first approach is manual. So you could say, oh, manual sounds quite expensive. But if it's a fresh new application, it's similar to logging. If you've been used to do logs, produce logs from out of the code, why don't you start producing traces out of your code? Similar journey. But we never start from there. Usually we start using the automatic and semi-automatic instrumentation that will instrument our well-known framework of the market. So for example, Spring in Java will be fully instrumented. If you use Python, there is a lot of popular framework like Django that will be also instrumented. There is plenty of various examples for every language. So at the end, if you rely on a framework, the good chance that the traces that will be produced will be quite accurate for your use case. And at the end, it will only produce data, but you will still need to send it to an observability backend to store the data that you produce. So what is a trace? Good question. A trace is a transaction. So I'm making an action. I will save, for example, an order. So the save order it will go through different components in my architecture, and that will be the trace. So to make this saving order, it will go through different sub-tasks within my architecture, within my microservices. So I will have subtasks, and those subtasks will be named spans. So at the end, a trace, very simple. It's a big JSON array of spans. So it's a list of spans. And everything to make the trace, we will need a context. So context have the trace ID and the span ID. And basically, with the help of the trace ID, this is how we attach all the spans together to make a trace. So a span has different information, so the name, the attributes, and so on, but we're not going to go too much into details. So if I want to build my traces in Go or Java or Node or whatever language, I will have a couple of objects that will be common to all of the SDK of OpenTelemetry. So first, if I want to build traces, I will add the OpenTelemetry API. Problem. From there, I will be able to create one trace provider. So the trace provider is basically the component that will help me to build my traces. And you can see that there is various objects involved. So they have the span processor, the sampler, the exporter, resources. So we will see those in details, but the span processor will help you to determine how you're going to send the data. Sampling is how much details we want to send. Exporter is where we're going to send the data. And resource is the identity of a service. And then we have a propagator. We'll talk about it in a few seconds. Once we have defined this, we will be able to definitely create our spans and our child spans. So what is a resource? Mention it's the identity of the service. So the resource is very critical because at the end, if you have a service card, service order, each of those services needs to have an identity. So then they will be basically displayed in the observability solution. So at the end, you need a service name, you need a service version. So a couple of things are required, but at least minimum is a service name. Tracing sampling, what it is? Well, we want to determine how much data we want to send to observability backend. Of course, we can send 100%, but that will be quite expensive at the end. So we need to sample and decide how we want to sample. At the moment, the OpenTelemetry project gives back, you have to configure the sampling decision by your own. So you have several sampling decisions available. You have always on, so 100% of the telemetry data produced will be sent to the observability backend. You have always off, which is the opposite, nothing. Then you have parent base. Parent base is perfect when you're a dependency, like service B, for example, in the slides, where I will define that only the trace, only the information from service B coming involved in a global transaction will be sent to the backend. Then you have trace ID based ratio, where you define basically a ratio, how many percentage, I say 20%, 10% of my data will be sent to the observability backend. And then you have combination of both, so parent base always on, parent based trace ID ratio, parent based always off, and so on. And so here in this example, I have service A, B, C, D, and E. And we're looking for an end-to-end trace. So the A I've been configured with trace ID ratio because it's the first endpoint. And the other one, we configured it with the parent-based trace ID ratio. So it will send the data from a global transaction where they're involved as a dependency. And we see that I've defined 20% for the service B, 50% on service C, and so on. But you can see that the numbers here, it's very important how you configure the sampling decision because you can have more or less details. So in this example, if I take 1,000 requests, out of these 1,000 requests, I will have only one end-to-end trace from A to E, which is quite low. So you have to tweak and configure it properly to get the right details that you need. What is trace propagation? Trace propagation, very simple. It's basically how the context will be sent to our architecture. So if I'm the first service A, I'm starting the trace. So I have the context very easy. So I can push it to all the various code because at the end it's the same code. I can keep the right context. But how can I make sure that the context will be sent over to service B and the trace will continue? Well, this is called propagation, where basically we will inject the trace context into before in our HTTP request, for example, in the case of an HTTP communication, and then we will extract in the service B, and then once we have the trace context, we can continue our trace. So now you know everything. Let's have an example. So in a traditional microservice architecture, distributed traces is just fantastic because here you can see that I have an ingress controller, I got several services. So with this, I will be able to keep track on all the tasks of a given transaction. And you have a very easy way to visualize this data. So for example, here I have an HTTP request going through various services in my architecture. So here I see that I have 25 milliseconds of this transaction. And if I want to optimize this transaction, I can clearly see that, okay, so we can see that list recommendation takes 20 milliseconds. So if I want to optimize, I may probably want to optimize that specific functions. And also what I discover here, I can get product that is called 1, 2, 3, 4 times. So maybe there's a more efficient way of doing it to reduce, again, the footprint of this transaction. So fantastic. But you say, okay, great, but you're talking about microservices. What's the relationship with event-driven architecture? Okay, be patient. I'm coming there. Well, for distributed tracing, it's a bit different. For example, you had a service, then I send my data to a broker or to a pub sub, whatever. And then based on that pub sub, based on that event, a couple of different services will start. So there's two different ways of doing it. The first way is, let's do a big trace. So from the service close to the ingress to all the various services that is being triggered through that event. So I will have a big trace, and you'll see that sometimes based on your architecture, it makes sense, and sometimes it doesn't make sense. So let's have a look at the first example, the end-to-end trace that I just referred. Very simple. So here I prepared for this event a GitHub repo. So here's the link, so you can play around. So here I'm using a PubSub architecture hosted on Solace. And I have the otel demo just to produce traces on the side. And then I have a demo. I have a publisher, and I have two consumers. One is on the REST and the other one in database. So let's have a look at how we can do that. What does it mean in terms of coding? So first, let's bring me the code of the publisher. So the publisher, nothing special. I'm going to look at the code here. So here you can see that we're using the OpenTelemetry SDK. Like expected, we have a batch span processor. So every single things that I explained, the sampling is defined. So first here I can see that I'm defining an exporter. So it's going to use the standard exporter of OpenTelemetry. I'm using a batch span processor to determine how I'm going to send the data. So this basically with that, I have a trace provider now. And with that trace provider, I'm able to start creating spans, which I'm doing here. Create span, start span. And as you can see here, I'm adding some attributes to give some details about this specific function. And then I will be able to attach the context. In the case of messaging, a couple of technology support and the trace context will be passed properly. And in this particular example, I'm using PubSub, so I don't have necessarily the SDK that does it automatically. So what I'm doing is I have a trace. Once I have the trace, I'm getting the trace ID and the span ID. So then I'm sending it as a property of the message, which means the consumer will have to extract it as well. So now if we look at one of the example of the consumer, like this REST consumer, same thing, we defined the trace provider, nothing special. And here you can see that from the message, I'm extracting the trace ID and I'm extracting the span ID. So once I have those, I am defining a new span context and I'm linking it and I'm restarting the child spans from there. So that's from the code perspective. But what does it represent in an actual trace example? So if I open my browser, I have it already displayed here. So first, let me bring me to the services. So which means here I got done a trace services. I have different applications running. And here you can see that I have, first of all, the consumer database, the consumer REST, those are the two things, and the publisher. So those are the information that the three services I'm running in my example. If I click on the publisher, I will have details about the actual services. But what I want to show you is the actual end-to-end trace. Remember, I start a trace, I send the context to the message, and then the consumer extract the context and continue their task as well. So I can see here now, I have a big trace with the publisher sending the data. And then I get every single details, I have the consumer REST and the consumer database. But the problem is, as you can see here, we have a 4 minutes transaction. And 4 minutes in terms of OpenTelemetry distributed trace is very difficult. So if I want to optimize the publisher, I have no idea because here it takes then a couple of 100 milliseconds. So if I want to reduce the publisher, I'm not able to have the details because technically it's not visible. So it's not perfect. So that's why I think we should improve in a way this because it's not well designed for our example. So you can see, this is what I was showing you. Is it a useful trace? The answer is, of course, no. I may need to change the way we're doing it. And the great examples is my second example, using span links. So before we start with these second examples, what is a span link? Well, in the case where you have a long transaction, in our case was not 2 minutes, but 4 minutes, you can see that the black span, which is in the first one, is mainly not visible. So if I have this, I can basically start a trace and then use a span link. So then the consumer will start a new trace and link that trace to the publisher. So at the end, I will have 3 traces with this implementation, one for the publisher, one for one of the consumers, and the last one for the other consumers. So at the end, I have 3 traces, much more easier to consume, much more easier to understand what's going on. So again, let's jump into the information. So I did a second version of this implementation where I changed slightly the code. So let me show you what I mean. So if we look at the code here, let me go back here. I go to the other example where it's the same REST that I showed you. So the publisher, I didn't change it. It's still sending the trace context in the message. I still need to extract my trace context, so trace ID and span ID. And here I'm starting a trace. And here you can see that I'm linking I'm creating a link to the actual context of the publisher. And then I'm starting a new span. And here I'm attaching a link. So it means that the code is slightly different. But what does it mean in terms of UI in your Observability backend of your choice? Well, let's jump into Dynatrace. And now I have another example where here, this is one of the examples, the rest that I was showing you. And you can see that I have 3 steps, much more simpler to use it. But what is interesting here, if I pay attention to the first one, I have here links. And then with that link, I can click on it and it will bring me back to the publisher trace. And you can see that I have a 100 millisecond trace, much more easier. And here I can see that if I want to optimize it, obviously I need to optimize the connect pub sub, which will be kind of difficult, but at least I know where I'm spending most of my time on that specific steps. Okay, so now that we've seen that, very important, let's jump into the conclusion. So first, pros and cons. So first, I would say using span links is great, but because at least it keeps track properly on the consumers. It's easier to visualize these things. But the major disadvantage that you lose basically the connection between the consumer and the publisher. From the consumer to the publisher, it's very easy. I know that this consumer comes from that trace, no problem. But from the publisher, I have no idea how many consumers has been triggered through that message. So it's more difficult to get a better vision, a broader vision of these things. The other disadvantage I would say is sampling decisions. We mentioned of sampling. Here I got a publisher trace and then I have a consumer trace. If those are 2 different sampling decisions, I may lose details. Maybe I won't have the publisher trace anymore, or maybe I won't have the consumer trace anymore. So again, it's not perfect, but it's easier to consume. So depending on your implementation, you will have to decide if you need an end-to-end trace or the use of span links. That's why it's an art to do observability. So first, as a takeaway, Make sure your code is agnostic, because again, the idea, we don't want to use any vendor locked in. That's the concept and the culture of OpenTelemetry. Second thing, if you start doing observability with using OpenTelemetry, make sure you have the right context in your metrics, in your logs, in your traces. Otherwise, you won't be efficient. And again, be creative. Understand your system. Design the right observability technique based on your application. All right, so just a small teaser of the YouTube channel Is It Observable? There is plenty of content covering OpenTelemetry and other observability framework or agents. So check it out. It's a quite young channel. So by looking at it, it will help me to be more efficient in the way I'm producing new content. All right, so I hope you enjoyed that session, that you learned some stuff. But if you have any questions, I will be very delighted and honored to answer to any of your questions. Thanks for watching. See you soon.